Welcome to Chemistry at Hononegah High School. I'm Brian Brown, and today we'll be looking at our third set of notes, which is a pretty short set of notes because I'm really wanting you to do one very specific thing. But after you leave here, there's a short movie I want you to watch that will set up these ideas and explain them just a small amount and also lead into what we're going to be looking at next tomorrow. Now, if you recall, we had two equations. The equation where we were looking at light acting like a particle, which was this one, which was the relationship between the frequency a bundle of light energy or photon had and its energy. And then the equation where we were treating light like it was a wave. The wavelength times frequency equals the speed of light equation. Now notice both of these have the same variable in it, which is the variable nu, which stands for the frequency. So if we take that second equation and solve it for nu, we end up with this, which we can then substitute in there, and we now have an equation that we didn't have before. In one equation, in our red box here, we have the relationship between a photon's energy and the photon's wavelength. And as the wavelength gets bigger, notice the energy is going to get smaller. That's because energy and wavelength are inversely proportional, just like frequency and wavelength are inversely proportional. So if we have a problem where they give us the frequency and ask for energy, we use the blue equation. If we have a situation where they give us the frequency and ask for wavelength, we're going to use the green one. And if they give us the wavelength and ask us for the energy, we can use the red one. And in each case, since we have two variables, we can actually solve for either variable once we manipulate the equation. And that's really what you're going to be practicing in your homework tonight. Figure out which of the three equations it is and write that down. And then solve that equation for the variable. And then finally, plug in your numbers and calculate. So you have to decide which of the three equations you're going to use. Now, before we finish notes, I want you to basically end up pausing this tape and watch one more short little movie because it does a nice job of showing how the frequency and therefore the wavelength is related to the energy of light. And this was a huge step forward in our understanding of the electrons inside an atom, which is where we're going next. So after this, we're going to get away from light and look at electrons. So this movie is really kind of a bridge between what's happening with light and what's happening with electrons inside an atom when an atom absorbs energy. And what you're going to be seeing is called the atomic emission spectrum or the bright line spectrum. And you'll see why. It's a series of bright lines that are not continuous. They're isolated with dark in between. So it's not a continuous spectrum like white light from the sun is, or from a glowing metal where we see the entire rainbow with no missing colors. It's a non-continuous spectrum. And that's what we get when we have glowing atoms. And our understanding of the electron and our understanding of some of these equations really is tied very, very closely to the bright line or atomic emission spectrum. So I want you to watch the movie labeled Atomic Emission Spectrum after we're done with notes here. And that's it for today's set of notes.